Okay, let's talk about some number laws. Now, you've heard me referring to our first number law fairly regularly. You've heard me talk about the distributive law, particularly when we're expanding out brackets, because that's what the distributive law is all about. Basically, it's about if we have something outside of a bracket being multiplied by things inside, or something on the outside that's multiplying by, you basically can redistribute the numbers in the fashion that is shown here. We can multiply this number that's on the outside by both of the terms on the inside separately, and that is the distributive law. So it's important when we are multiplying out binomials and all that sort of stuff that we are using the distributive law. The next law that I'd like to talk about is a law that we have referred to in the past. I'm just sort of reminding you about. It's the next of the big three for algebra, and that's the commutative law. So the commutative law really is looking at reverse positioning, I guess, of our terms and whether that works. So here, look at the first example. X plus y is equal to y plus x. Doesn't matter what order I do my addition in, I'm going to get the same answer. So I can rearrange stuff if it makes it a little bit easier for me and it's all addition, because I know it's all added in any order. Okay, but what about subtraction? Well, subtraction unfortunately does not hold true to the commutative law. The direction in which you're subtracting is actually important. So for this example that I've got just here, it's 2 minus 3. Well, that's going to equal negative 1. And this 3 minus 2, that's just going to be 1. And negative 1 does not equal 1. So our commutative law does not hold true for subtraction. Okay, well, what about multiplication? Well, it holds true. Y times x is equal to x times y. 3 times 2, which is just 6, is equal to 2 times 3, which is 6. So that holds true. Doesn't, however, hold true for division. X divided by y is not the same thing as y divided by x. 2 divided by 3 is 2/3. 3 divided by 2 is 1.5. Definitely not the same thing. Okay, so that's the commutative law. It's the arrangement in terms of how things are worked out. The next law is it's the last of the big three that people know about if you talk about number laws in algebra, and that's the associative law. Now, the associative law really is about the brackets and the association of the brackets in different ordering pairs, like different order. So here we've got an x plus and then brackets of y plus z. Well, if I change that to move the brackets around the x and the y, well, does that still work? Yeah, it does. It still adds. They associate, right? Addition is associative. However, subtraction is not associative. It doesn't work in the same way. It has to be done in a particular order. As you may have guessed, the multiplication is associative. Doesn't matter what order I do multiplication in, but division definitely doesn't work in terms of its association. So we can say that the addition and multiplication work for the associative law. There's a couple of other number laws that you may not recognize the name of them, but you'll recognize the maths behind them. The first of these is the identity law. The identity law, really, it's a pretty simple idea. The first one is that if you're adding 0 to any number, you're really just staying at the same number. So if I've got x and I'm adding a 0, I'm really just got x. Adding a 0 doesn't really do anything. Just like with multiplying by 1, if I have any number and I multiply it by 1, I really just have that number again. So again, the identity of x does not change despite what I have done to it. I can multiply it by 1, I could add 0, but its identity is maintained. That's the identity law. Nice quick one. The next law, another sort of simple idea, is the inverse law. So the inverse law basically states that if I have a number and I add the inverse of that number, the negative of that number, then you will end up at 0. Okay, so any number plus its inverse equals 0. That's the inverse law for addition. There's also the inverse law for multiplication. So if I multiply by the inverse, then I'm going to end up at 1. Okay, so 1 over x, what's the inverse? It's just x. So 1 over x times x, it will leave me with 1. Okay. Now, the good thing about this is if we have something like this, let me quickly draw it. If I've got 2x and I'm multiplying it by 1 over x, then I know that this and one of these x's, this x here, will just cancel out, right? This will just be 1 and this will just be 1, and 1 divided by 1 is just 1. And I know because of the identity law that 2 times 1 doesn't change the 2. It maintains its identity, and the answer will just be 2. Okay, so you can use these laws in conjunction with each other. The last law is one that you may have never heard of before, never have considered it even maybe. Let's have a look at it. It's called the closure law. The closure law really is when you're performing an operation on some part of a set, right? So, for example, if I was adding the number 2 and the number 4, well, they're both part of our natural counting numbers. And they actually, when you add 2 and 4, you'll get 6, which is also a member of the natural counting numbers. So it actually, in that instance, the 2 plus 4, the answer will stay within its own set, so closure law is true for that particular operation. It's best to see these as examples, this closure law, so it'll make a bit more sense. So again, it's all about the set of the numbers that you're dealing with, okay? So if the numbers that you're given, first thing you've got to do is figure out what set do they belong to. Well, now, x being 4 and y being negative 12, well, they are not part of our natural counting numbers, so that's not part of that set. Negative 12 means that they're integers because they are whole numbers on a number line, integers. Okay, so that's the set we're dealing with. So we have to check to see if when we do an operation with these numbers, are we getting answers that are integers? Well, let's have a look. If we have x plus y, so 4 plus negative 12, we get negative 8. Is negative 8 an integer? Yes, it is. That is part. It fits the closure law. Closure law applies. What about x minus y? 4 minus negative 12 will give us 16. Is 16 part? Is it an integer? Yes, it is. So therefore, closure law applies. What about x multiplied by y? Well, x multiplied by y, 4 times negative 12 gives us negative 48. Is negative 48 an integer? Yes, it is, so closure law applies. And what about the example of x divided by y? Well, 4 divided by negative 12, our answer is negative 1/3. Now, 1/3 is not a whole number. It's not an integer. So therefore, this instance, this particular version of our operation does not give us an answer that the closure law applies to. It's outside of that. Okay, now it's important that you can't just blanket like our distributive law, our commutative law. The commutative law only ever applies for addition and multiplication. But the closure law, it applies in different ways at different times. Have a look at this example. If I've got surds and I do root 2 multiplied by root 3, well, that'll give me root 6, which is a surd. So it holds true for the closure law. But if I have root 2 multiplied by root 2 and it gives me an answer of root 4, well, I can actually work out root 4. Root 4 is 2, and 2 is not an irrational number like the other numbers. It's not part of the set. So therefore, the closure law does not hold true for that one. You have to check these closure law, if you're using something to do with that, on each individual case. Okay, so that's some number laws. The big important ones are the first three: the distributive law, the associative law, and the commutative law. These other ones are just the laws that allow you to work with some ease in algebra, so we can divide things and make things disappear.